Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So, young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT, JEE, SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.
Hi, hello, dear students. Welcome back you all to the second session of 7th day of our 16 days MCQ challenge hosted by Brilliant Qatar. See, dear students, we know that you have entered into the serious preparation for your board examination and you see to grab your dream marks. And similarly, see, your examination is actually 12 days far from you. And if you have not started your preparation seriously yet, it is the high time to start your preparation, because the examination is only 12 days for your examination is starting on 24th. See, dear students, if any of the student is sitting with laziness without starting your preparation, I wanted to remind that students also to start your preparation very seriously to grab your dream marks. We Brilliant team will be there with you, behind you, with you, always to help you out in academics to score you the dream marks that you are expecting. Okay. See, I am here in front of you to discuss a few important questions from chapter electricity. Electricity is a very important chapter, It contains a lot of varieties of numericals, and similarly it contains varieties of, formulas. All has to be used, all has to be applied for solving different types of numericals. This chapter is not similar to the other chapter. Like first chapter is light reflection and refraction. It is a big chapter, but it does not contain that much huge number of formulas. But the chapter electricity contains a lot of formulas, a lot of ideas, a lot of techniques. So this chapter is very important. And similarly, the magnetic effect of electric current and human eye and the colorful world, these two chapters also little theoretical chapter. So electricity chapter is actually very important. And see, dear students, my words will be incomplete without appreciating you, because in all the lives that we have conducted till today, all of you have participated, actively, consistent participation was there, energetic participation was there in all the lives. Your comments, your answers, everything is actually giving a lot of energy to us, to the teachers. We are hosting this live. Okay. So anyway, without wasting much time, see, dear students, we are entering into our first question. Our first question is displayed here. This is our first question. Everyone read the question very carefully and start answering it. A cylindrical conductor of length L and uniform area of cross-section A has resistance R. The area of cross-section of another conductor of same material and same resistance but of length 2L is. The options are A by 2, 3A by 2, 2A and 3A. You might have come across this question, dear students, before, maybe in our class, but still you will have to try to solve it with pen and paper, and you will have to answer it in the comment box. See, dear students, look at the question very carefully. A cylindrical conductor of length L and uniform area of cross-section A has a resistance R. Okay, so let us consider a conductor. This is our conductor. That we are considered, and this conductor is having a length L. Okay, this conductor is having a length L and it is having a uniform area of cross-section A. Okay, this conductor is having a length L and it is having a uniform area of cross section A. And see, suppose we are considering the resistivity of this conductor as rho, and we will be considering its resistance as R. Okay. Now this conductor will be having a resistance, right? How much will be its resistance? We know that that is R is equal to rho L divided by A. This is the equation for resistance that we have studied, because resistance is directly proportional to the length of the conductor, and resistance of the conductor is inversely proportional to the area of cross section of the conductor. Okay. Now you see, second part of the question is what? The area of cross section of another conductor of same material and same resistance, but of length 2L is. That is, we are having another conductor. Okay, this is the second conductor that we are having, and similarly, see, its length is 2 times of the former length, right? Length is 2 times of the former length. Okay, and similarly, its area of cross section has to be found. Suppose its length is 2L. Okay, 2L is the length, and similarly, area of cross section A dash. We will be considering area of cross section of the second conductor as A dash, and its resistivity is actually rho only, because both are made up of same material, correct? And we will be taking its resistance as R dash. See, dear students, don't confuse. We are taking R here and we are taking R dash here. In the question, it is given that both are having same resistance. Don't worry, we will be equating it finally. Okay. Now, what is the resistance of the second conductor? R dash is equal to rho into length is 2L, right? Rho into 2L divided by, you see, what is the area of cross section? Area of cross section is a dash. Okay. So this is actually R dash is equal to 2 rho L divided by A dash we will be having. Now in the question, it is given that both the resistors are having, both the wires are having, both the conductors are having same resistance. So we will be able to equate R is equal to R dash, correct? R is equal to R dash. So R is what? R is rho L divided by A, and what is R dash? R dash is a 2 rho L divided by A dash. Okay, so what all things will be cancelled in this? See, dear students, rho L is cancelled, rho L is cancelled. So what will come? We will be having 1 by A is equal to 2 divided by A dash, and A dash will be equal to 2A. Okay, A dash will be equal to 2A. What was A dash? A dash is actually the area of cross section that we have taken for the second conductor, in which the length of the second conductor is double of the first conductor. Okay, so A dash, we found A dash as 2A. That is, we will have to take a conductor double of the area of cross section of the first conductor. Okay, I hope all of you have got the correct answer. See, when I am looking into the comment box, yeah, most of you have given the correct answer. Very good, dear students. I would like to appreciate you. All of you have given the correct answer only. C option. Yes, the correct answer is 2A only. Okay, 2A only. 2A. Yes. Let us go to the next question. See, the maximum resistance which can be made using 4 resistors, each of resistance 1/2 ohm is. What will be the maximum resistance that we are able to obtain by connecting 4 resistors, each of 1/2 ohm resistance? What will be the maximum resistance? Yes, I am waiting for the comments, your answers. I am waiting for your answers. Yes, still the answer for the first question is displaying. Yes, second question is this. What is the maximum resistance that we are able to get by connecting 4 resistors, each are having 1/2 ohm resistance? See, dear students, how do we can calculate it? We all know that, see, maximum resistance will be obtained when multiple number of resistors are connected in series, right? In series, we will be getting maximum resistance, and in parallel, we will be getting minimum resistance, right? Okay. So, if 4 number of resistors are having 1/2 ohm connected in series, what will be the maximum resistance? How can we find it? See, series combination RS is equal to NR. Are you familiar with this formula? How do we are getting this formula? Suppose we are having multiple number of resistors with the same resistance connected in series. See, RS is equal to R plus, etc. N times R, and RS will be equal to NR. Okay, NR. So RS is equal to NR. How many number of resistors we are having? 4 number of resistors we are having, into each resistors are having 1/2, which is equal to 2 ohm will be the maximum resistance. Okay, 2 ohm will be the maximum resistance that we are able to obtain by connecting 4 resistors each are having 1/2 ohm resistance. Okay, and similarly, see dear students, if I am asking you a question, in the same question, if I am asking you what is the minimum resistance that we are able to obtain by connecting all these 4 resistors each are having 1/2 ohm resistance, what is the minimum resistance? Can you comment it? Can you comment that value? Can you comment that value? See, when n number of resistors are connected in parallel, what is the equation for effective resistance? That is, all the resistors are equal in amount. All the resistances are having equal in amount. So, see dear students, 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R plus etc. Okay, n times 1 by R will be having, if n number of resistors are resistors with equal resistance connected in parallel. Okay, so it comes to be 1 by Rp is equal to n into 1 by R, that is n by R. And what is Rp? Rp is equal to R by n. Okay, this is the equation for effective resistance if n number of resistors each are having same resistance connected in parallel. Okay, so in parallel we will be getting effective resistance very minimum. So Rp is equal to R by n. This is the formula. What is our R value? Our R value is a 1/2. 1/2 divided by how many numbers we are having? 4 numbers we are having. Okay, so this is equal to 1/8 ohm. 1/8 ohm will be the minimum resistance. Yes, very good. Mayank has commented the correct answer. Okay. Yes, Advik Jain have commented the correct answer. Many of you have commented the correct answer. The minimum resistance that we are able to obtain is a 1/8 ohm if 4 number of resistors each are having 1/2 ohm connected in parallel. Okay, but this is not our question. Our question is actually 2 ohm is the answer for our question here. Okay, 2 ohm. This I have given as an additional information only. So let us go to the third question, dear students. Yes, here is your third question. See, read the question very carefully and try to answer it. In the following circuits, heat produced in the resistor or combination of resistors connected to a 12-volt battery will be same in all the cases, minimum in case 1, maximum in case 2, maximum in case 3. Which will be the correct option? All of you, please try to find out the correct answer and comment it. See, I am giving you a few seconds. See, even without doing any mathematical calculation, you will be able to get the answer for this question. Correct. Even without doing any mathematical calculation, you will be able to get the correct answer for this question. But still, you see, I'm just calculating the amount of heat energy dissipated in all the 3 cases. Okay. So, first of all, we will have to calculate the amount of heat energy. Okay. First of all, we wanted to calculate the amount of heat energy in the first case. Okay. So, we can take it as H1. What is H1? H1 is the amount of heat energy in the case 1. This is case 1. Okay. So, what formula we can choose? V square divided by R into T. This formula can be used. So, H1 is equal to, what is potential difference given here? 12 volt is the potential difference given here. 12 square divided by, what is the resistance? 2 ohm is the resistance here. So, 12 square divided by 2 into T we can take. So, H1 is equal to 12 square is 144 divided by 2 into T. So, H1 is equal to 72 T joules. Okay. Since T is not given here, we will have to keep it as T only, right? We are, keeping these 3 circuits open for the same time only. So, we are keeping it as T only. So, 72 T joule of amount of energy will be dissipated in the first case, that is first circuit. And in the second circuit, we will be able to calculate using the same formula. H2 we can take, H2 is equal to V square divided by, we can take it as R1 and this as R2 T. So, H2 is equal to, again 12 square divided by R2 is how much, dear students, in this circuit? 2 ohm resistors are connected in series. Then R2 will be how much? 4 ohm will be the effective resistance, right? So, 12 square divided by 4 into T will be having H2 is equal to 144 divided by 4 into T, and H2 will be equal to 36 T joules. Okay, half of 72, 36. Okay, that is the amount of energy we will be having. And in third case, how much amount of energy it will be dissipated? Third case, it is H3, which is again V square divided by R3 into T, which is equal to 12 square divided by, what is the effective resistance in the third case? Effective resistance is only 1 ohm, right? Because two 2 ohm resistors, two 2 ohm resistors are connected in parallel, then the effective resistance will be only 1 ohm. So 12 square divided by 1 into T, which is equal to 144 divided by 1 will be 144 only. That much T joules amount of energy. Okay. See, look at this, dear students, in which case maximum amount of the heat energy is dissipated. In the third case, maximum amount of the heat energy is dissipated. Okay. We will be able to write it as H3 is greater than what? H3 is greater than H1 is greater than H2. This is the order of heat dissipation. Okay. This is the order of heat dissipation. See, this question you don't want to do this whole calculation. I have just shown you some calculation only, but even without doing this whole calculation, you will be able to get the answer for this. I will show you that. See, which formula I have chosen here. H is equal to V square by R into T. H is equal to V square by R into T. See, dear students, why did I choose this equation only to solve this question? I have some another formula, right? H is equal to I square RT is there. H is equal to VIT is there. Why did I choose this formula only? H is equal to V square by R into T. It is because in all the three circuit, what is common? Potential difference is common. Okay. How much is the potential difference? That is 12 volt. Here it is 12 volt and here also it is 12 volt. Okay. So potential difference V is constant. Then we will be able to understand the relationship between heat energy dissipated and resistance clearly. Okay. What will be the relationship? Heat energy dissipated is inversely proportional to the resistance. Heat energy dissipated is inversely proportional to the resistance. That is, in the minimum resistance circuit, maximum amount of the heat energy will be dissipated. Under what condition? At a constant potential difference. Okay, at a constant potential difference. See, in all these three circuit, potential difference is constant, and out of these three circuit, minimum resistance is there in the third case. That is the reason why maximum amount of the heat energy will be dissipated in the third case. Okay. So maximum in case 3 will be our answer. Okay. All the rest of the answers will be wrong. Okay. So majority have done the correct answer. Majority have done the correct answer. I would like to appreciate everyone who have given the correct answer. See, dear students, you guys are really rocking. I have seen that in all the lives that we have, conducted in the last days. I was watching all the subject lives, and you see, because of seeing your energy only, the majority of the teachers are coming to take the live. Actually, your energy is, very high. Okay. See, keep up this energy till 20th February, till the end of our live session. Everyone have to participate, with full of energy, with full of power. We all will be there with you till the end of your board examination through online as well as through offline. Okay. Next question. Two resistors are connected in series, gives an equivalent resistance of 10 ohm. When connected in parallel, gives 2.4 ohm. When then the individual resistances are each of 5 ohm, 7 ohm and 4 ohm, 6 ohm and 4 ohm, 8 ohm and 2 ohm. What will be the answer? All of you please try to do it, by taking your pen and paper, solve it and comment the answers. Yes, all of you, please come forward. I'll give a hint to do this question. Two resistors are connected in series, gives an equivalent resistance of 10 ohm. How can I write it mathematically? See, each resistors are having R2, suppose. R1 is first resistor plus R2. R1 plus R2 is the effective resistance in series combination. Correct? How much is that? Which is given in the question, which is 10 ohm. Which is given in the question, that is 10 ohm. When connected in parallel, gives 2.4 ohm. Okay. If two resistors which are having R1 and R2 ohm are connected in parallel, what will be the effective resistance? What will be the effective resistance? See, dear students, we know 1 by Rp is equal to 1 by R1 plus 1 by R2. Okay. So 1 by Rp is equal to cross multiply R2 plus R1 divided by R1 R2. Then Rp will be what? Which is R1 R2 divided by R1 plus R2. Okay. So effective resistance in parallel combination will be R1 R2 divided by R1 plus R2 will be equal to 2.4 ohm. That is given in the question. Okay. Now see, substitute this value of R1 R2 is equal to 10 ohm here. Okay. Then R1 R2 divided by 10 is equal to 2.4. R1 R2 is equal to 10 into 2.4, which is equal to 24. Okay. R1 R2 is equal to 24. See, R1 plus R2 is what? R1 plus R2 is equal to 10 and R1 R2 is what? 24. See, which are the two numbers by adding we are getting 10 and the same two numbers by multiplying we are getting 24. Which are the numbers? 6 and 4, right? 6 and 4. Okay. So by solving these two formulas, we will be able to get R1 is equal to 6 ohm and R2 is equal to 4 ohm. Okay, R2 is equal to 4 ohm. So which option will be correct, dear students? Which option will be correct? Our option B will be correct here. 6 ohm and 4 ohm. Yes, everyone are commenting. I do appreciate you again. Yes. Vidya Lakshmi is there. Crazy Gamer is there. Samir is there. Then Namira is there. Okay, it's me. I don't know who is me. Okay, please come with your real name there so that we can call your name, right? Okay. So let us go to the next question. If R1 and R2 be the resistance of the filament of 40 watt and 60 watt respectively, operating 220 volt, then R1 is less than R2, R2 is less than R1, R1 is equal to R2, R1 is greater than or equal to R2. Yes, all of you, please do try to do it. See, this is a very easy question, right? R1 and R2 be the resistances of the filaments 40 watt and 60 watt. See, we are taking the power of 40 watt bulb as P1 and we are taking the power of 60 watt. The 60 watt will be taking it as P2. Okay, P1 and P2. See, R1 is the resistance of 40 watt filament and R2 is the resistance of the 60 watt filament. See, we will be able to write the formula for power. P is equal to V square divided by R. P is equal to V square divided by R. Okay. Now see, both are operating at same potential difference, right? Both are operating at same potential difference. Now we will be able to say that this power is inversely proportional to the resistance at a constant potential difference. Power is inversely proportional to the resistance. Okay, power will be inversely proportional to the resistance. Now you see, if power is inversely proportional to the resistance at constant potential difference, because both are operating at a 220 volt potential difference. Okay, at a constant potential difference, power will be inversely proportional to the resistance. So the filament that is having lower power, okay, the filament that is having lower power will be having higher resistance. Okay, will be having higher resistance, and the bulb that is having higher power will be having lower resistance. Okay, because power and resistance are inversely proportional when potential difference is fixed. Okay, so which option will be correct? The resistance of the filament of 40 watt bulb will be larger, that is R1 will be larger. Okay, R1 will be larger or greater than R2. Okay, R1 will be larger than R2, which means that which option is correct? See, R2 is less than R1, right? R2 is less than R1, so option B will be correct in this. Okay, so this relationship you will have to understand. Power is inversely proportional to the resistance. Less is the power, higher will be the resistance. Okay, less is the power, higher will be the resistance. One condition is there, at a constant potential difference. Very important. Okay, at constant potential difference. And see, dear students, at constant current, what is the relationship between resistance and power? Power is directly proportional to resistance, because we know that P is equal to I square R. This formula we have studied, P is equal to I square R. Okay, this formula mainly will be using in series combination, correct? In series combination, current is fixed, so it will be easy to choose this formula. But in parallel combination, potential difference will be constant, so it is easy to choose this formula in parallel combination. Okay, so in series combination, power will be directly proportional to the resistance. In parallel combination, power will be inversely proportional to the resistance. That is, at constant potential difference, power will be inversely proportional to the resistance. At constant current, power will be directly proportional to the resistance. Okay, these two things also you will have to add, as a extra knowledge to you. And we are going into the next question. Yes, a coil in the heater consume power P on passing current. If it is cut into halves and joined in parallel, it will consume power P by 2, 2P and 4P. Yes, everyone give a try to do this question. Yes. See, if you are having pen and paper with you, just to try to substitute according to the changes that is asked to change in the question. Okay, by cutting that resistance into two halves, each pieces will be having R by 2 resistance, right? Then R by 2 and R by 2 are connected in parallel. We will be getting a particular amount of resistance, and that has to be added in the new power formula. Okay, I will show you that. Don't worry. See, suppose we are having a resistance wire here, which is connected with a potential difference V. R is the resistance of the resistance wire. Okay, and suppose I is the current flowing in the circuit, right? Now, how much will be the power dissipated by this resistance wire? P is equal to V square divided by R I am taking. Okay, P is equal to V square divided by R is the formula. Now you see what we are doing. If it is cut into halves, that is this resistance wire, if I am cutting into halves and joined in parallel, okay, that is, I am just drawing one more diagram here for that. These are the two resistors that I am getting by cutting it into two halves. So this will be having R by 2 ohm. This will be having another R by 2 ohm, because total resistance is R for this conductor. If this is cutting into two equal halves, each will be having R by 2 ohms, right? Okay. So if two R by 2 ohms are connected across the same potential difference, see how much will be the effective resistance of this. That is 1 by Rp is equal to 1 by R1 plus 1 by R2. 1 by Rp is equal to 1 by R by 2 plus 1 by R by 2. 1 by Rp is equal to 2 by R by 2. Okay. And we'll be having 1 by Rp is equal to what? 4 by R. And what will be our Rp? R by 4 ohm. Okay. R by 4 ohm will be our effective resistance when these both are connected in parallel. Now you see, dear students, we will have to find out the new power. What will be our new power? We can take it as P dash. P dash is equal to V square divided by, what is our resistance now? R by 4, right? So V square divided by R by 4, which is equal to V square into 4 by R, that is 4 V square divided by R, which is equal to 4 into what? V square divided by R is what? Our previous power before we are cutting the resistance wire into two equal halves. Okay, so P dash, that is new power, will be 4 times P. Okay, P dash, that is our new power, will be 4 times the initial power that we had. Okay, so which will be the correct answer? Which will be the correct answer? The correct answer is 4P. Okay, that is the power will become 4P. Yes, everyone are commenting. Yes, you guys are really rocking. Again, Advik Jain, again, Isha Jalil, these guys, okay. Vidyalakshmi, same people are commenting multiple number of times. Saeed Musa, UWUD, Jos P, okay, Sri Sharan, everyone are commenting. Yes, dear students, I appreciate you. Okay. Yes, look at the next question, dear students. SL, a resistor, a key, and an ammeter are arranged as shown in the circuit diagrams. The current recorded in the ammeter will be. Yes. Look at the question. It doesn't need any mathematical calculation. It is an easy question. You will be able to solve it without doing any calculation in the paper or in the book. All of you, please look at the question very carefully and answer it. Yes. I am waiting for the comments because it doesn't need any mathematical calculation. Yes. Which one will be correct? Maximum in case 1. Second option is maximum in case 2. That is maximum in case 3. And D, same in all the cases. Yes. The answer will be same in all the cases, right? The answer will be same in all the cases. Correct. Answer will be same in all the cases. D option will be correct. Okay. D option will be correct. Why it is same in all the cases, dear students? See, when we are connecting a circuit, we will have to take care of something. Correct. What are those something? See, when we are connecting a resistance wire, a cell, a plug key, an ammeter, voltmeter, everything, see, we will have to consider some rules. What are those rules? When you are connecting an ammeter, it has to be connected always series in the circuit. Okay. Which are the points that you will have to remember? Ammeter will be always connected in series. Okay. Always connected in series. Okay. Then next point is what? Voltmeter. Voltmeter will be always connected in parallel. Always connected in parallel. Okay. And similarly, next point that you will have to remember is positive of the cell or positive of the battery should be connected. Positive of cell should be connected to positive of voltmeter and ammeter, and similarly negative of the cell should be connected to negative of voltmeter and ammeter. Okay, so negative to negative and positive to positive, these all things you will have to remember while connecting this. Okay, see here everything is fulfilled, right? Because positive of the cell is connected to the positive of the ammeter, negative of the cell is connected to negative of the ammeter, and ammeter is connected in series. Here also the same thing is there, here also the same thing is there. What is the difference between these three circuits? The position of the ammeter is only different. Position of the ammeter, position of the key, positions are only different, but they all are there in the circuit in series, and their terminals are also, their polarities are also connected properly. So there is no any mistake in any of the circuits, and we will be getting same current in all the circuits. Okay, right, let us go to the next question. Yes, DS, look at this question. Calculate the current through 10 ohm in the following circuit. Yes, resistors network question, very important question. This kind of question you can expect for 2 mark or 3 mark even, dear students. Okay, so take this question very seriously. This is actually can be expected as a 2 mark question to find out the effective resistance of the circuit, and to find out the total current in the circuit, and to find out the potential difference across each and every resistors in the circuit. Okay, many questions can be added into it, but in our question you just to find out the current through 10 ohm resistance only. Okay, how much will be the current? See, in order to find out the current through 10 ohm resistance, dear students, first of all we wanted to find the total current in the circuit. Okay, I will help you to find out the total current in the circuit. First of all, how will you solve this circuit? How will you find out the effective resistance of the circuit? See, can I consider this R1 and R2 are in series? I cannot consider R1 and R2 are in series, students, because what is the condition for two resistors to be in series? Same current should flow through both the resistors. Then only we will be able to say that these both are connected in series, right? But here this R2 is coming after a junction here. From this junction the current has got splitted, right? Okay, so the current that is flowing through R1 is not equal to the current flowing through R2. I cannot consider these two are in series. But at the same time, see, I'll tell you. Suppose I is the current that is coming from the battery. Okay, now I is the current that is flowing through R1. But I, when reaching at this point, it will be splitting into two currents, that is I1 and I2. Correct? It will be dividing into I1 and I2. Now tell me, what is the current flowing through R4? That is also I2, right? That is also I2. So we can say that R3 and R4 are in series. First step is what? R2 and R4. R3. Okay, sorry. R3 and R4 are in series. Okay, they are in series. Now how can we solve it? See, RS is equal to R3 plus R4, which is equal to 6 ohm plus 4 ohm, which is equal to 10 ohm, right? Okay, so we got the effective resistance of R3 and R4 as 10 ohm. Now you see, we will be able to redraw the circuit, right? We will be able to redraw the circuit like this. That is, you see, this R3 and R4 can be replaced with a single resistor, that is our RS, which is equal to 10 ohm, and this is our R2, which is equal to another 10 ohm, and this is our R1, which is equal to 7 ohm, and this is our V, which is equal to 24 volt. Okay, now see, dear student, what is the next step? This R2 and RS are in parallel, correct? R2 and RS are in parallel. R2 and RS are in parallel. Okay, now what is the effective resistance? 1 by RP is equal to 1 by 10 plus 1 by 10, which is equal to 2 by 10. And you see, what will be RP then? RP is equal to 10 by 2, which is equal to 5 ohm. Okay, 5 ohm. So we got the parallel effective resistance of this parallel combination is found to be 5 ohm. Now again, I'll be able to replace this R2 and RS with a single resistance, that is with 5 ohm, right? Okay, so like this we can connect. R1 will be there. Now instead of R2 and RS, we will be having only one resistor, that is RP, which is equal to 5 ohm. Instead of R1, we will be having same resistance, that is 7 ohm. Okay. What is the next step? Next step is R1 and RP are in series. Then what is the effective resistance? R1 and RP are in series means we can take it as RS dash, which is equal to R1 plus RP, that is equal to 7 ohm plus 5 ohm, which is equal to 12 ohm. Okay. So the effective resistance of this entire circuit has been calculated, which is equal to 12 ohm, right? Now, what is the total? What is the total current in the circuit? See, what is the formula for I? I is equal to V by R. What is V? Total potential difference is 20 volt, which is given in the question. So 24 volt divided by what is the total resistance we calculated? That is 12 ohm, which is equal to how much? 2 ampere will be the current. Okay. Total current in the circuit is how much? 2 ampere. Is 2 ampere is our answer? 2 ampere is not our answer. What is our answer? What is our answer? Our answer will be 1 ampere, right? Okay. Why our answer is 1 ampere? Because 2 ampere is the total current in the circuit. Okay. Total current in the circuit. Total current means I. I is the total current. When that I reaches at this junction, it has got splitted into two equal halves, right? Because this 2 ampere current, when reaches at this junction, it is reaching two different paths, each are having same resistance. See, this path is having how much resistance? 6 plus 4. And this path is having how much resistance? Another 10. 6 plus 4 is 10 and this is also 10. So this 2 ampere will get equally divided into 1 ampere and 1 ampere. So through this our R2, how much resistance? Through this our R2 means through our 10 ohm resistance, how much current will be flowing? 1 ampere current will be flowing. Okay. 1 ampere current will be flowing. Okay. See, dear students, this type of question, network solving questions, are very, very important for your board examination. Please do practice maximum number of network question, which is very, very important. Okay. See, simple to complicated type of network of resistors question has to be practiced. We have practiced it offline in offline classes, and similarly work it out by getting from different practice papers. Okay. Now see, an additional question I am asking to you, that if you are asked to find out the potential difference across R1, how will you find it out? Can you tell me, dear students? What is the potential difference across R1? For example, if I am connecting a voltmeter here, how much will be the reading of that voltmeter? Tell me. Yes, everyone. How much will be the reading of that voltmeter? What is the equation for potential difference? V is equal to I into R, correct? V is equal to I into R. How much is I through R1? How much is I through R1? 2 ampere, correct? Okay, 2 ampere. So 2 ampere multiplied by how much is R1? 7 ohm. Okay, so 2 into 7, 14 volt will be the potential difference, correct? 14 volt will be the potential difference across this R1. 14 volt will be the potential difference across R1. Okay. Now see, dear students, how much potential difference is left? What is our total potential difference? 24 volt is the total potential difference. 14 volt has gone across R1. Now the rest of the potential difference is how much? Only 10 volt. That 10 volt will come across the parallel combination of what? Parallel combination of R2 and RS. Clear, dear? See, when I am connecting, see, I'll tell you clearly, when I am connecting a voltmeter here, it will read 14 volt. Okay. Now, if I am connecting a voltmeter here, it will read how much? It will read 10 volt. Okay. Which means that across this R2, we are having 10 volt, and similarly across this RS. RS is the combination of R3 and R4. Okay. So a total across R3 and R4 will be having 10 volt. So tell me how much will be the potential difference across R3, that is 6 ohm. 6 volt only will be there. What will be the potential difference across R4, that is 4 ohm? How much will be there? 4 volt only will be there. Okay, 4 volt only will be there, right? So we have calculated the current, potential difference, everything across all the resistors. See, one by one I'll tell you. The potential difference across R1 is 14 volt. The current in R1 is 2 ampere. Correct. Now, the potential difference across R2 is 10 volt and the current through R2 is 1 ampere. Okay. Potential difference across R3 is 6 volt and the current through R3 is 1 ampere. Potential difference across R4 is 4 volt and the current through R4 is also 1 ampere. Okay. So this type of question can be expected to calculate potential difference current through each resistor. Okay. So this type of question has to be practiced more in numbers, dear students. Okay, next question. A current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through a cross section of the filament in 16 seconds would be roughly. Yes, everyone. This is an NCERT exemplar question. Everyone, please do try to solve it. Yes. Everyone. Yes. Come on. Yeah. I'm waiting for your comments. It needs a simple mathematical calculation, okay, by using a very common simple formula that we have studied in the chapter electricity, in the starting of the chapter electricity. Very basic formula. First formula that we have studied in this chapter has to be used here, okay. See, first of all, we will be writing the given values. What is the current here? Current is equal to 1 ampere. A current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through a cross section of the filament in 16 seconds would be roughly 10 to the power 20, 10 to the power 16, 10 to the power 18, 10 to the power 23. Okay. So first of all, current is equal to 1 ampere. What else is given in the question? See, time is given, t is equal to 6 seconds. Okay. What else is given? See, nothing else is given, but we know the charge of a single electron, correct? Charge of single electron is how much? Everyone, yes. E is equal to 1.6 into 10 to the power negative 19 coulomb. Okay. This is a common value that everyone have to remember. Charge of single electron is 1.6 into 10 to the power negative 19 coulomb. Coulomb is the SI unit of electric charge. Okay. Right. Now, see, what is the equation for finding current? I is equal to Q by T. What is the definition of current, dear students? It is the amount of charge flowing through the cross-sectional area of a conductor in 1 second. That is what is current, right? Okay. So, I is equal to Q by T is the formula. But you see, we know what is Q is. What is Q? Total amount of the charge. See, dear student, what is flowing in the conductor? Electrons are flowing, right? What is flowing in the conductor? Electrons are flowing. Okay. If 10 number of electrons are flowing through the cross-sectional area in 1 second, if 10 electrons are flowing in the cross-sectional area of the conductor in 1 second, how much will be the total charge? 10 into 1.6 into 10 to the power negative 19, correct? 10 into 1.6 into 10 to the power negative 19. So total charge, how can we get? Total charge we can get by multiplying number of electrons multiplied by charge of single electron, correct? So Q is equal to NE is the formula, very important basic formula that we studied initial part of the chapter, okay? So this formula can be replaced as I is equal to NE divided by T, and from this N has to be calculated because number of electrons has to be calculated. N is equal to what? N is equal to I T divided by E. Substitute the values. I is 1 into T is how much? 16 divided by charge of single electron is, we know that 1.6 into 10 to the power negative 19. Okay. Now this is equal to N is equal to 16 divided by 1.6 is what? 10, right? 10 into 10 to the power negative 19 in the numerator. If I am taking it into denominator, if I am taking it into numerator, it will become 10 to the power plus 19, right? Okay. So 10 into 10 to the power plus 19 is what? N is equal to 10 to the power 20. Okay. 10 to the power 20 number of electrons will be there to constitute 1 ampere current. 1 ampere current, to flow in 16 seconds. Okay, 16 seconds. So this is actually another very important question, right? Next question. Look at the next question. See, dear students, look at the next question very carefully and try to answer it because it needs some mathematical calculation. All of you, please try to do it. Yes. Come on. Two bulbs rated 100 watt 200 volt and 50 watt 200 volt are connected in parallel across a potential difference of 200 volt. Okay. What is the total current taken by the circuit? What is the total current taken by the circuit? Full circuit, how much will be the current? That is actually the question, dear students. Okay. See, 0.5 ampere, 0.25 ampere, 1 ampere, 0.75 ampere. These are the options that we are having. Okay. So first of all, let us have a diagram for the circuit. Two bulbs rated 100 watt. So first bulb I'm connecting here. Second bulb is having rating 50 watt and 200 volt are connected in parallel. So second bulb is connected like this. Okay, two bulbs are connected in parallel like this. Yes. Okay, first bulb is having a rating 200 watt, 200 volt. Okay, second bulb is having 50 watt, 200 volt, and the total potential difference is how much? 200 volt. Okay, this is a circuit diagram. Now see dear students, we wanted to find out the current passing through first bulb. We can give name for different bulbs. Okay, we can give this as B1 and this as B2. Okay, current passing through B1 can be taken as I1, current passing through B2 can be taken as I2. Okay, now we wanted to find out I1 and I2, and both has to be added. We'll be getting the total current. How can we find it out, dear students? How can we find it out? See, which formula has to be used? And before that, let me ask you one question. What is the meaning of writing something like this? 100 watt, 200 volt. What is the meaning of that? Writing something 100 watt, comma 200 volt. What is that actually? What is that? It is actually power rating, we'll say. Okay. Power rating. What is the meaning of power rating? See, when I'm saying 100 watt, comma 200 volt, when 200 volt potential difference is given to this bulb, when 200 volt potential difference given to this bulb, it will dissipate a power of 100 watt. Okay, when 200 volt potential difference is given to this bulb, it will dissipate a power of 100 watt. That is what is the meaning of power rating. Okay, see, in this circuit, both B1 and B2 are getting 200 volt potential difference because both are connected in parallel, right? Okay, B1 is getting 200 volt potential difference, B2 is also getting 200 volt potential difference because total potential difference 200 volt is connected parallel to B1 and B2, correct? So B1 will consume how much power? 100 watt power. B2 will consume how much power? 50 watt power, because both are getting 200 volt potential difference from the circuit, correct? Yes. Now we'll be able to find out the current by using the easy formula that we studied. See, P is equal to V into I. Do you remember a formula like this? Yes, P is equal to V into I. Okay. For first bulb, we can take it as P1 is equal to V into I1. Now, what is I1? I1 is equal to P1 divided by V. Okay. That is I1 is equal to, what is P1? That is 100 watt divided by how much is V? That is 200 volt. Okay, so I1 is equal to 100 by 200 is 1 by 2 ampere is the current. 1 by 2 ampere is the current flowing in which resistor, dear students? That is in B1 only. Okay, B2, how much amount of the current will be flowing? We can calculate in the same way. See, P2 is equal to V into I2. What is I2? I2 is equal to P2 by V. That is, P2 is how much? P2 is 50 watt divided by voltage is 200 volt, right? Both are getting 200 volt only because 200 volt is the common potential difference that we applied. And this is equal to what? 1 by 4 ampere, correct? 1 by 4 ampere. So B1 is carrying a current of 1 by 2 ampere and B2 is carrying a current of 1 by 4 ampere. Now total current is equal to I is equal to I1 plus I2. I is equal to 1 by 2 plus 1 by 4. What is that? 4 is the LCM. Then 2 plus 1, 3 by 4. So what is I? I is equal to 3 by 4 ampere, which is equal to 0.75 ampere. Okay, 0.75 ampere will be the total current in this parallel circuit, dear students. Okay, a very important type of question. This question you can expect for 2 mark also. Okay, 2 mark or even 3 mark type of question, you can expect this type of question to find out the total current in the circuit by giving the rating of the bulb. Okay, rating of the bulb. Yes, so 0.75 ampere is our correct answer, and yeah, majority of you have given the correct option. Yes, crazy gamer have given with steps. 0.5 plus 0.25 is equal to 0.75. Yes. And everyone are commenting D. Yes, correct. Very good. Excellent. Yes, next question. If the current I through a resistor is increased by 100%, assume that temperature remains unchanged. The increase in power dissipated will be 100%, 200%, 300%, and 400%. Yes, read the question from your side. See, carefully read the question from your side and answer the question. This is another question from, you see, exemplar question, which is very important, which is asked in the previous year board examination. Okay, previous or before that, it has been asked anyway. Okay, recently this question has been asked in the board examination. Very important question, dear students. See, I'll tell you, if the current I through a resistor is increased by 100%, for example, we are having a circuit like this. Yes, R is the resistance, V is the potential difference, and suppose I is the current flowing in the circuit. Now, how much will be the power dissipated? P is equal to I square R we are taking. Okay, P is equal to I square R we will be taking. Now, what change we are doing in this? If the current I through a resistor is increased by 100%, okay, that is, we are increasing the current by 100%. By increasing the current by 100%, what will happen for the current? That is, 100% of I is what? I only. 100% of I is I only. So with I, we are increasing 100% of I, means with I, we are adding another I. So what will be the total current? After making this 100% increase, the current will become 2I. Correct? The current will become 2I. Okay. So if the current become 2I, see, we will be able to make the new power, that is P dash we can take. New current, after increasing the current 100%, the new current will be 2I. So replace I with 2I. 2I square into R will come. Correct? 2I whole square into R will come. And now it has to be solved. P dash is equal to 2 square is 4I square R. Okay, 4I square R. This is the new power. This is the new power that we are having after increasing the current 100%. Correct? And dear students, one more thing you will have to remember, which is very important. Assume that the temperature remains unchanged. Okay. What is the importance of that statement? Assume that the temperature remains unchanged. If the temperature changes, what will happen? If the temperature changes, our resistance will change. Correct? Resistance will change, because temperature and resistance, temperature increases, resistance will increase. Correct? So just like that, you see, if R changes, our power, also will be changing. So by this statement, what does it mean is resistance doesn't change. That is, resistance, due to changes in the resistance, there is no any change. There is no any change happen for the power. Okay, that is a point here. So dear students, what is the new power? 4I square R. Now, what is increase in power? What is increase in power? Increase in power is equal to P dash minus P. Increase in power means a change in power, right? Which is equal to, what is P dash? 4I square R minus initial power is I square R, and this is 3I square R. 3I square R will be our increase in power. Okay, that is, the power is increased by how many times? 3 times the power is increased. Okay, 3 times power is increased. Okay, now percentage increase in power. Actually, here it is asked to find the percentage wise. Percentage increase in power will be equal to P dash minus P divided by P into 100. We'll have to get the, how much percentage will be that. 3I square R will be how much percentage of I square R. Okay, that has to be found. So this is equal to what? 3I square R divided by P dash minus P is what? 3I square R divided by P is what? I square R into 100. And this is I square R and I square R is cancelled. 3 into 100 will come. 3 into 100 will come, which is 300%. Okay. 300% will be the increase in power. 300% will be the increase in power. That is the answer for this question. Okay. Yes. Everyone are commenting. Very good. Ahini Sara, Samir again answered. Advik Jain, Sanvi has answered. Okay. Then Medansh Dev is there with the correct answer. Yes. Everyone are commenting the correct answer only. Thank you so much. Keep this energy, throughout our all classes. See, dear students, we are there with you till your board examination ends. Okay. Actually, we wanted to be your proud teachers after declaring your result. That is the reason why we are taking these all efforts. And you see, along with that, you should be the proud son or daughter of your parents also. so that you see they also will get pride, right? Okay, see, please do remember that. And those who didn't start their preparation for board examination, today onwards you will have to take a right decision, a strong decision to start the preparation. See, I know that many of you are spending only 1 hour or 2 hours for your studies right now. Okay, I know that in a day that is not enough, dear students. Okay, you will have to wake up maximum number of hours, you will have to find for your studies, then only you see you will be able to score the highest marks. See, whatever the marks that you have scored in the pre-board examination, you forget it. Okay, if you have scored the highest marks in the pre-board examination at your school, keep it up. Okay, and similarly, if you have scored less marks like 40 or 50, you will have to learn from that. Okay, learn from that and go ahead, right? Others, those who have highest score, have to keep it up. Others have to learn from that and come up. Okay, keep this in your mind. With that energy, you will have to start your preparation. And we are going into our next question, that is this: if two bulbs, both of rated power 100 watt at 220 volt, are connected in series with a 220 volt supply, the total power consumed by the bulbs will be? Yes. Come up, all of you, come up with your options. Here, dear students, we are having both the bulbs with same rating, right? Same rating. Okay, I'm going to draw a circuit diagram for that. Yes, first bulb is this and second bulb is this, and both are connected with a potential difference of how much? 220 volt. First bulb is having a rating 100 watt, 220 volt, and second bulb is having a rating of same only 100 watt, 220 volt. Both are rated with same rating only. Okay, both are connected together with same potential difference, that is 220 volt power supply. What is the total power consumed by the bulbs will be? Okay, see, dear students, don't think that the total power consumed is 100 plus 100, that is 200. That is not the correct answer. Okay, why that is not the correct answer? Because the total potential difference supplied is 220 volt. See, I told you in another question before, that is, what is the meaning of this rating? What is the meaning of this rating? Power rating is what? That is, when 220 volt potential difference is given, it will be consuming a power of 100 watt. Okay, but is this bulb B1, I am giving it as B1, is B1 bulb is getting 220 volt? No, B1 bulb is not getting 220 volt, because this is series combination. In series combination, potential difference will go splitted. Correct, potential difference will go splitted. Okay, that is, out of this 220 volt, this B1 will be getting only 110 volt. Okay, B2 will be getting another 110 volt. But if it is in parallel, both the bulbs would have getting 220 volt potential difference. But in series combination, potential difference will go splitted. Okay, so don't think that the total power is 100 watt plus 100 watt, which is 200 watt. That is not the correct answer. We wanted to find the new power of the entire circuit, in this way. I'll show it to you. First of all, we wanted to find out the resistance of each bulbs. Okay, what is the formula for power in terms of V and R? That is, P is equal to V square divided by R. And you see, what is the equation for resistance from this? R is equal to V square divided by P. Correct. And what is V? V of the B1 is, when 220 volt potential difference is given, 100 watt power will be dissipated. Okay, so 220 square divided by 100. Okay, which is equal to, what is 220 square? 222 is 484. Then 00 divided by 100 will be there, which is 484 ohm. Okay, 484 ohm will be the resistance of one bulb. Correct. Now we wanted to find out the total power, right? Total power. So what will be the total resistance of the entire circuit? One bulb will be having 484 ohm and two bulbs will be having how much power? We will have to multiply that with 2. Correct. We will have to multiply that with 2. So 484 into 2. 968, right? 968. Okay. So total resistance is equal to 968 ohm. Total resistance of the circuit will be 968 ohm. Now the power dissipated will be equal to P is equal to, see, what is the formula? V square divided by R. What is the total potential difference applied? The total potential difference applied is 220. So 220 square divided by total. We wanted to find the total power of the circuit. So we wanted to consider the total resistance of the circuit, which is 968. 968, that is equal to 220 whole square will be 48400 divided by 968. This is 484 is half of 968, right? So this will be 2, which is 1 by 2 into 100, which is equal to 50 watt will be the total power. Yes, everyone are commenting. Very good, very good. You guys are really rocking. Yes, 50 watt will be the total power dissipated in this case. Okay, 50 watt will be the total power dissipated in this case. Yes, yes. So dear students, come up with this type of question, because these type of questions are very important, which need some calculation. See, this question can be asked as 2 mark also. I told you this question can be expected as a 2 mark question also, because this much calculation has to be done, right? Okay, this much calculation has to be done. So this is another very important type of question. Let us go to the next question. Yes, a very easy question, you know, without a second thinking you can answer it, right? The resistivity does not change if the material is changed, the temperature is changed, the shape of the resistor is changed, both material and temperature are changed. See, when the material changes, resistivity will change. When the temperature changes, temperature increases, resistivity will increase. Okay, why temperature increases, resistivity increases, dear students? Do you know? When temperature increases, the electrons, the particles inside the conductor will be randomly moving with very high speed. Correct, with very high speed. So due to that random motion with very high speed, there is a chance for collision between the particles, right? Collision particles means electrons and positively charged ions are there inside the conductor, right? Free electrons and positively charged ions are present inside the conductor. These both will undergo maximum number of collisions, and that will be blocking the smooth flow of the electron inside the conductor. Okay, so by increasing the temperature, speed or random motion of the electrons will be increasing, and thereby number of collisions will be increasing, and more opposition will be there, and thereby resistance will or resistivity will increase. Okay, right. The shape of the resistor changes. If the shape of the resistor changes, resistivity will not change. So this will be our correct option. Okay, both material and temperature is changed, then resistivity will again change. So our answer is what? The shape of the resistor is changed, resistivity does not change. Okay, option C will be correct. Next, 15th question. An electric toaster has a power rating 200 watt. It operates for 1 hour in the morning and 1 hour in the evening. How much does it cost to operate the toaster for 10 days at rupees 5 per kilowatt hour? Okay, at rupees 5 per kilowatt hour. What is the answer, dear students? Everyone with full of energy, come up and answer. Solve it by using pen and paper and answer it and comment it. Yes, yes. Yes, yes, comment it. Yes, I'm waiting. Yes, along with you, I also will do, because we are having limited number of time only. Yes, yes. See, an electric toaster has a power rating 200 watt. What is the power? 200 watt. Okay, 200 watt. It operates for 1 hour in the morning and 1 hour in the evening. So total time it is working is 2 hours, right? How much does it cost to operate the toaster for 10 days at rupees 5 per kilowatt hour? So first of all, we wanted to calculate the total amount of energy it consumed. Correct. Total amount of energy it consumed. Okay. See, what is the total amount of energy it consumed? Energy is equal to power multiplied by time, right? But we wanted to get the amount of energy in kilowatt hour. To get the amount of energy in kilowatt hour, we wanted to multiply power in kilowatt with the time in hour. Okay. Power in kilowatt with the time in hour. Power in kilowatt means 200 watt will be how many kilowatt? 0.2 kilowatt. 0.2 kilowatt multiplied by time in hour is 2 hour. But for how many days it is operated? 10 days it is operated. So we'll have to multiply with the 10. Okay. So 0.2 into 2 is 0.4 kilowatt hour into 10 days, which is equal to 10 into 0.4 is, see, 10 to 0.4 is 4 kilowatt hour is the amount of energy it consumes. Okay, each kilowatt hour cost 5 rupees, so it will be total cost will be 4 into 5 rupees, which is equal to 20 rupees will be the cost. Okay, 20 rupees. Which option will be correct? Our option A will be correct. Our option A will be correct. Okay, okay, dear students. So we have completed 15 questions in this 1 hour. 15 questions are PYQs. All the 15 questions are PYQs, previous year question, which are asked in the board examination. So with this question, since our time is out, we are winding up our session, and we will be coming up with the rest of all the important questions. We will be stay tuned with you till 20th February. You also will have to stay tuned with us with this full energy, and you see, we will be seeing in the next class with another set of very, very important question. Till then, bye, good night, take care.
Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So, young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT, JEE, SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar.